All right, so we've got one of these dilations where it's not centered at the origin, and we have to remember that what that means is that we're taking the distance away from the center point and multiplying it by the scale factor, meaning that whatever this distance is right here, so that distance, is going to be multiplied by 5/2 to get this distance. And you don't have to do the diagonal distance. You can do the rise and the run and multiply the rise and the run both by 5/2. All right, so it's got these confusing things down here. So we just got to kind of look at what's going on. So it says PA is equal to AA prime. So that is saying that this distance is the same as this distance, and that's just not true. The only way that would be true is if it was doubled, multiplied by a scale factor of 2, so that's out. AB is parallel to A prime B prime, all right? That's almost definitely true, okay, because what happens is when you dilate something, the slope doesn't change, all right? So that's a good thing to think is probably true. AB is equal to A prime B prime. There's no way that's true, all right? And then 5/2 times AB, A prime B prime equals AB. This is smaller, all right? This is smaller. So there's no way I multiply the bigger one times 5/2, which is bigger than 1, and get the smaller one. All right, I'm going to write down slope stays the same in a dilation. And this is another example of a problem, if you've been doing some Regents problems, where if you're not sure, just look at it, okay? There's no way 3 and 4 are true by just looking at it. There's no way, all right? And if I have to choose between 1 and 2, 2 looks true, all right? So I'm picking that based on just looking at this. And that's a benefit I have with multiple choice questions on a geometry test.